Hello there, folks. We're going to talk about day 3 of chapter 2. What it's going to be on is it's going to be on density curves and the empirical rule. We're kind of working our way into the normal distribution. So let's go ahead and get started. Okay, so first thing we're going to just talk about is density curves. So here's the thing. This is a histogram. And what we're going to find out is, and the calculus people usually will see this a little quicker, is that to try and figure out areas, it would be really nice if this was kind of smoothed out. So that's what a density curve is. What a density curve is it takes this kind of jagged curve and it turns it into a smooth curve. So, I mean, this isn't perfect, but it kind of does something along the lines of this. And realistically, what it's supposed to be doing is it's supposed to kind of smooth everything out to where, you know, these areas here in white are areas that don't have data. These areas here in gray are areas that do have data. It's so that they roughly offset one another. So whatever the area is that's outside above that pink and whatever's below it kind of offsets. So now what happens is we have a smooth curve. We can actually use some rules of calculus using the calculator that actually help us figure out area under the curve. So that's what a density curve is in its simplest form. Okay, so next thing we want to talk about is we want to talk about the normal distribution. Normal distribution, many people have seen it before. If you haven't, this is what the normal distribution looks like. Let's just kind of go over some rules of the normal distribution. As you notice, it's bell-shaped, it's symmetric, and it's unimodal. So bell-shaped, kind of shaped like a bell. Symmetric, could fold it in half. Unimodal, one mode. We measure a bell curve or a normal distribution. We measure it using the mean. The mean falls right here in the middle. This is where the mean would be. And what we end up doing is we count standard deviation. So the way we reference the standard deviation is we have a normal distribution with a mean or a center of mu and a standard deviation of sigma. And what ends up happening is the way we look at this is going to be +1 standard deviation. This is going to be +2 standard deviations. This is going to be +3 standard deviations. -1 standard deviation, -2 standard deviations, and -3 standard deviations. Okay, so that's our normal curve. Okay, and the normal curve follows a certain kind of set of percentages that are pretty standard, and it's called the empirical rule. You'll oftentimes hear it referred to as 68, 95, 99.7. What it is saying is that 68% of the data is within 1 standard deviation of the mean. So what it's saying is that the area between these two spots right here is roughly 68%. What it's saying is that almost a little over 2/3 of the data falls within 1 standard deviation of the mean. The next one follows that 95%, so out to here. That gives us 95% of the data. And then when we go out to this last standard deviation, or not the 3rd standard deviation, we're at 99.7%. So that is kind of an idea of like that roughly 99.7%, or so in essence, almost all of our data is within 3 standard deviations of the mean in a normal distribution. I also have these numbers here because they're nice to know that if 68% falls within 1 and this curve is symmetric, if I were to cut it in half, cut it right down in half of 68, 34, and 34. And basically what these numbers are what happens. So from here to here is 95. If you cut 95 in half, it's 47.5 on either side. If 34% is here, 13.5% is there, and so on out. So 3 standard deviations. In the extreme here, it's 0.15%. So it's 0.15% here. It's 0.15% here. So that's in the extremes, and be careful, that's 0.15%. So as a decimal, it would be 0.0015. It's a good thing to know when we're using it. We're going to do some calculator stuff as well, but occasionally, if you're presented data, you can actually draw some conclusions just based on that. So I'll do a quick example. Let's say I have a normal distribution with a mean of, let's say, 32 and a standard deviation of 4. And I were to ask you, how much data? So what percent of the data? What percent of the data is contained between, let's say, 24 and 36? Well, if you think about it, 24 is 2 standard deviations below. So it's 2 standard deviations below. 36 is 1 standard deviation above. So what that means is if I go 2 below 34 and 13.5 gives me 47.5. 1 above that 34. So this tells me 47.5% is here. 34% is here. When I add those together, I get 81.5%. So that's a quick example. There'll be some problems that we are doing in class to kind of talk about it, but that's the empirical rule. The empirical rule is a nice way to kind of quickly get an answer. You can also do this in the calculator. So hopefully that kind of helps. That'll wrap up our day 3. On day 4, we're going to do a lot of stuff in the calculator, so make sure you have it there with you. Thanks.